All right, so what's going on here, guys? They ask us in 13, 14, it's the same way. It says, take this polynomial and show that c equals -1 is a 0, and c equals 3 is a 0, okay? Now, there's two ways that we can do this. We can use what we call the remainder theorem, okay, which I explained in the video yesterday, basically saying that when I evaluate at c, my remainder, if it is 0, that tells me that I have a 0 of the function. Does that make sense? Okay. So we could do that, and we could say, you know, whether it's going to be a 0 or not. So if I say P of C, if I evaluate at C and I get 0, that is proof that because my remainder is 0, that this thing is a 0 of P of X. Okay. Basically, it's telling me my Y value. Does that make sense? Okay. Now, you can do that here, and it will work. If I go 2 times -1 to the 4th, minus 15 times -1 cubed, plus 10 times -1 squared, plus 45 times -1, plus 18. Okay? You can go through and evaluate this stuff. So it's going to be 2, plus 15, plus 10, minus 45, plus 18. Okay, so it gives me 25, 27, 27 plus 18 is 45. So I have -45 plus 45, it gives me 0, right? Okay, so that could be proof that it is indeed a 0. All right? Now, is that the greatest approach? Based off this question, my answer to that is no. Because what does the next part of the question ask you to do? It asks you for the remaining 2 zeros. Okay? Well, this does not help me transform my polynomial into a remaining 0, or to find the remaining zeros, okay? What this does do for me, though, guys, is tells me that if -1 is a 0, then x plus 1 is a factor, right? Does that make sense? So if we think about this, now you don't have to write this down because we'll do it in a better way here in a moment. But we can have x plus 1 as a factor, but now we'd be looking, okay, what is left over when I factor an x plus 1 out of that? Well, what's a fancy word for factoring? Or factoring is a fancy word for what? Division. So really, we could say, to find out what goes in here, I could take 2x to the 4th minus 15x cubed plus 10x squared plus 45x plus 18, and could I divide that by x plus 1? And that quotient then, okay, would be what goes right there. Does that make sense? And then I could kind of repeat the entire process again with that. That's time-consuming, going that route, using that type of notation, and to use that version of division. So this is kind of what we want to do in this problem. And really, from here on out, this is what we're going to do with all these types of problems. We're going to do synthetic division. Now, synthetic division parallels right along with long division. Okay, they're really the same thing. Think about long division. Okay, if I had 2x to the 4th minus 15x cubed, 10x squared plus 45x plus 18, and we divide by x plus 1. Let's see how this parallels to synthetic division. If you're going to do this long division, we really don't think about it as division with polynomials. We kind of work backwards and say, okay, what can be my factors? What can I multiply x plus 1 by so I get 2x to the 4th? Well, what does that have to be? What does the coefficient have to be so you get 2x to the 4th? Has to be 2, right? Now, the variable term has to be x cubed, correct? Okay. But now, what I would do next is I would take this 2 multiplied by this stuff out here, 2x to the 4th, and it would be plus then 2x cubed, right? Okay. And then I told you we're going to subtract, okay, or multiply by a -1 and add the opposites, right? So let's cancel out, and it gives me, what, negative 17x cubed. And we start bringing down our other parts, right? And then we repeat the process. Let's show how that's the same as synthetic division. With synthetic division, okay, so what goes out in this box out here is the solution to the question of my factor equals 0. What is the solution to that equation? Okay, so it'd be -1, right? So a C term is what goes out here. That is the zero of the polynomial. Does that make sense, everybody? That's what's going to go in that box. Then we put our coefficients out of our polynomial, 2, negative 15, 10, 45, and 18. Okay. Now, if we're doing this with long division, I talked about it on the video yesterday that if you're doing long division, the purpose of a placeholder isn't all that important as long as you're consciously thinking about what you're doing every step of the way, so that you line up your terms correctly. Obviously, it's a benefit to have a placeholder in long division, but in synthetic division, it's an absolute necessity that you put placeholders in it, okay? Meaning that if I didn't have like an x squared term, if it went from negative 15x cubed all the way down to 45x, that I put in 0x squared as my placeholder. Does that make sense, everyone? Okay. If you don't do that, your synthetic division is going to go awry, and you're going to be confused and wondering what's going on and all that kind of stuff. All right. So the first step of synthetic division is to bring that 2 down. What does that mimic? It mimics finding that 2 right there. Does that make sense? Okay. Then we'll multiply by negative 1. We'll multiply by this factor right here, negative 1 times 2 gives me negative 2. What does that mimic? That stuff right there, correct? Okay. So then the rest of this is going to mimic kind of that repetitive process of the long division. So synthetic division is the same exact thing. Is that right with everybody? I think that's important for us to realize as we start to make conclusions here in a moment. Multiply gives me negative 7. Add straight down gives me negative 17. So now take negative 1 times by negative 17. And that product goes here. Gives me positive 17. Add straight down gives me 27. Multiply by negative 1 gives me negative 27. Add straight down gives me 18. Multiply then by negative 1 gives me negative 18. And that's my remainder. Is that okay with everybody? And that would be analogous to when I get through with the long division, my last term will not have a remainder. I'll have nothing left over. Okay? Okay. So what does that tell us? That tells us that when we did the long division, this thing was 2x cubed, right? That was my quotient. That means this is my quotient. So that's 2x cubed. This is 17x squared. This is 27x. And this is 18 as a constant. Does that make sense to everybody? Okay. Now, synthetic division I talked about yesterday is that we're going to do it with only linear terms. Okay. Linear factor. So, long division, I could do that. I could do x squared plus 1 as my divisor and see what I get. That's not going to be as clean with synthetic division. Okay. The nice thing about synthetic division, though, as well, is that it doesn't have to be real zeros. They could be complex, which we'll talk about later on, maybe Thursday or Monday next week. But that's nice. So what does this mean, guys? This means that P of x right now tells me 2 things. Yes, this indeed was a 0, because my remainder theorem tells me I had a remainder of 0, so that's where this thing crossed the x-axis. But it also tells me this. If that's a 0, x plus 1 is a factor, and we call it a linear factor, and then 2x cubed minus 17x squared plus 27x plus 18 is kind of what we call a cubic factor. Does that make sense?
Is that what you want to put in the box?
No, I'm not worried about what you type in there. I mean, that's when they ask you to show your work or something like that. Yeah, you would put all that, and that's kind of going to be difficult to type in, right?
Yeah.
Okay, so just going to ignore that type of thing. And unless I tell you otherwise throughout the rest of the year, when it has boxes like that says explain your work, and your work has to be kind of like this, you can say lower. I'm looking for you to
explain so that now I'm really stressed out about it.
Yeah, it's really hard to use that math type to get that in there correctly. So we get that depreciated. I call this a depreciated polynomial. Okay, what's the word depreciate mean?
Lower.
Yeah, it's lower, right? If you drive your car off the car lot, it depreciates instantly, right? Meaning the value of it goes down, right? Okay. Very few things that you consume appreciate. Okay. But this is depreciated, meaning that we started with a 4th degree polynomial, and now what we've got left over is this 3rd degree. It went down by 1 degree, right? And that 1 degree that went down by is accountable for or from that x plus 1. Okay? So the next thing they ask you to do is try the same thing with 3. Okay? Now I just want to make sure that we understand this. So let's see if I can do this or explain this well with just some regular numbers, okay, some real numbers. So let's say I take 36, and I ask you, is 36 divisible by 2 and 3? Okay? You can do this 2 ways. You can go 36 divided by 2, and you get 18, right? You go 36 divided by 3 and get 12, correct? So we're going to answer it that way, right? So how does that play into what we're doing here? I could take this thing here again and put a 3 in this box out here and go through this process. Does that make sense? But doing that is going to give me like an x minus 3 here. Okay? And then it'll give me another cubic, right? That doesn't really help me target how to find the next set of zeros. So here's my question. If I wanted to ask, is 36 divisible by 2 and 3, can I do it this way? Is 36 divisible by 2? What's that give you? 18. If 36 is divisible by 2 and 3, then that means 18 better be divisible by 3 as well. Gives me 6, right? Does that make sense to everybody? Now I can do it in reverse order. I can go 36 divided by 3. Gives me 12, right? Okay. 12 divided by 2, does that give me 6 again? Okay. So that kind of analogy there maybe helps us realize that I'm not going to go back up to this polynomial and divide it by 3 again. Because what we just learned with real factors, rational factors, is that I should be able to divide the depreciated 36 by that remaining factor. Does that make sense? Okay. So I'm going to take this 2x cubed and divide it now by the 3. Because remember, what is this polynomial, guys? What's it doing when I know what x is? Isn't it just giving me a real number back? Okay. That real number might be 36. Who knows? Okay. But the things that we do with just general real numbers transfers over to polynomials here. Bring my 2 down. Multiply gives me 6. Bring my, negative 11 down. Multiply gives me negative 33. Add those together gives me negative 6. Multiply gives me negative 18. What happens there? Gives me 0, right? So what's that tell me? It tells me that this p of x, this original p of x, was divisible by x plus 1 and x minus 3, right? So it tells me p of x was divisible by x plus 1, x minus 3, and when I divided p of x by those two things, it led me first to an x cubed. Divide by another linear term. What should this x be raised to? The second power. So now I can rewrite p of x that way. Does that make sense? Okay. Now, also, it doesn't matter the order that I would have gone here. I think most people, just because of the way it was presented, would have tried negative 1 first, and then tried 3. Okay? But you could divide it by 3 first, and then divide it by negative 1, because 36 divided by 2, and then divided by 3, same thing as 36 divided by 3, and then by 2, right? Okay? So, why is this useful? Why is this better than starting over at the beginning and dividing this thing by x minus 3? Okay? Is because it now depreciated everything down to a quadratic. Do you have the ability to factor that quadratic? Okay, and this is the reason we spent so much time at the beginning of the year trying to factor quadratics and learning all the processes for those, is because they will generate in every one of these problems. Every single p of x that we come to that is greater than x squared will depreciate at some point to an x squared, and then we have to use our factoring processes to get that to go even further. Okay, so I'm going to start with 2x squared minus 11x minus 6, and right away I see that 2 and that negative 6, and I see a negative 12 in my head, right? And when I see negative 12 in my head, there should be a negative 11 with it. Okay, so we're using the negative 12 in what we call the AC method, right? Negative 12 times positive 1 will give me that negative 11. So I have 2x squared minus 12x plus 1x minus 6. Group first two, group last two. Factor out 2x out of the first two. So it'll give me what? X minus 6. Factor a 1 out of the back two gives me x minus 6 again. So now I have 2x plus 1 and x minus 6. That can take place of that quadratic. So I have x plus 1, x minus 3, and now that quadratic turned into x minus 6 and 2x plus 1. And that then, folks, is the depreciated, the completely factored p of x, 2x to the fourth minus 15x cubed plus 10x squared plus 45x plus 80. Okay? Now, if you wanted to, and I think this is a good idea, obviously I don't want you to sit and have to, once you get that, we should be able to FOIL that and get back to p of x, right? Now, FOILing, that's probably going to be kind of 2 iterations of FOILing, and then one iteration of multiplying a trinomial by a trinomial. So you've got several steps of multiplying there if you're going to do that. My suggestion, you can do a quick YouTube search, or not YouTube, Google search to find this type of thing, or just use GeoGebra. But you can ask a calculator a lot of times, has an algebra system in it, to just expand this and just to verify that yes, indeed, we do have what we're looking for. So just type in the function, ask it to expand it, and see that it does give me back what we started with, right? Okay. Now here's something I like to do. Can that 2 be factored out of there? If I factor, I can factor anything out of anything that I want to, right? Because factoring is just dividing. I can divide anything by anything, except unless it's 0, right? Divided by 0. So I pull this 2 out. And let's put the 2 right there for now. So I put the 2 out. So divide it out. That'll give me 1x here, right? What would this term here be? 1/2. Okay. Now I don't like that because this is all multiplication, right? So the multiplication operation. Is it commutative? So you gotta move that 2 all the way out here, and then hit enter. Still gives me the same thing, right? Now, why do I like doing it that way? Looking at those, then I can instantly take a glance and realize that my zeros are -1, +3, +6, -1/2, right? If that 2 was multiplied through that factor of x plus 1/2, so it was looking at 2x plus 1, I got to do a little bit of work. It's not hard mental math, but I got to do a little bit of work to get that 0, right? If I factor, so all my coefficients of my x's are 1s, then it's just kind of a visual cue. It's real quick to tell me what my zeros are. Okay? Is that all right, everybody? Now, why is this doable in this situation? What was the key information they gave you? They gave you those C values, right? They have to give you those to get the ball rolling. After today, they don't. Okay, so I want to talk about today the logic of where they're getting these numbers.